As our quality of life increases, there are also unexpected effects that come from that. And so as Asia continues to develop, there's more and more demand for energy, but energy requires fuel and combustion, cars, power plants, and all of these things will emit into the atmosphere. And these emissions have clear health effects. Sometimes we talk about the long-term effects of climate, but there's a short-term effect which has to do with our health. And mainly it has to do with respiratory responses. And so breathing air of poor air quality that has both gases that are toxic as well as fine particles that reach deep into the lungs are a real concern, especially in large cities where you have people gathering together in larger and larger amounts and their activity levels create air that can be very unhealthy.
This is an opportunity where satellites can see air pollution being transported, and we can work together with our partners at other agencies and in other countries to help reduce this problem that is both causing premature death and also contributing to climate change.
In developing areas, air pollution is playing a larger and larger role in health. The Korean Peninsula is ideal because it's isolated. So not only can we look at what's happening locally in Korea, but we can also see what's coming in from outside the country. And the separation of that peninsula by water gives a clear separation between what's coming from upwind and then what's happening locally. The other thing that we can find in Korea is that the population density is very concentrated, and so the gradient between the city and the rural areas is very, very strong. And so being able to look at how natural emissions and anthropogenic or human emissions mix together is a great setting in Korea for looking at that. So we talked in 2011, but it wasn't until 2012 that we thought this is something that we could make happen.
And then I started talking to Jim about whether NASA would be interested, and we've done experiments quite a long time ago near Asia, but here was an opportunity to actually do an experiment in East Asia.
And there's a lot of inertia in politics to overcome, because you must come up with a good plan, you must convince your agencies that the plan is worthwhile, and again, you must also pick a partner. And in the Korean community, we saw a lot of very good work going on, especially in the modeling community, and saw a real opportunity to work with them.
This KORUS-AQ program was the first international collaboration in Korea for air qualities. We've never been in this huge program before.
So often in the past, we had been going to other international locations and working alone. Here, with Luisa's help, we had a chance to work as a team with the Koreans.
This KORUS-AQ mission will give us a really good experience, and probably our Korean scientists will do some days just do our own mission. So it was a really good opportunity for us to learn a lot.
KORUS-AQ offered us an opportunity to, for a very short, intense period, measure atmospheric composition as it relates to air quality broadly across the Korean Peninsula for many different substances that are not typically measured.
Sometimes there's pollution transported upwind from another country, but it just stays up high and doesn't get mixed down to the surface, whereas the satellite has a hard time seeing the altitude of the pollution. And so we can see both transport, and we can see the impact on the local community when we do these aircraft campaigns where we're vertically profiling, going up and down, tying it to the satellites.
So the most important pollutants that we have in the atmosphere are not directly put in the atmosphere, but they're the result of other things that we have placed in the atmosphere through burning fuels. Combustion is a large problem. And so what happens is the atmosphere is trying to chemically cleanse itself. And as the atmosphere does that, it creates more toxic substances that are ultimately removed from the atmosphere. The two most important toxic substances are ozone and fine particles. Ozone, because of its reactivity, reacts with lung tissue. So as you breathe high levels of ozone, you're actually creating a chemical reactor inside your body that is damaging to the lungs. For fine particles, We really would like to understand what the particles are made of, but largely at this point in time, we focus on particles that are small enough to reach deeply into the lungs, and those are particles smaller than 2.5 microns. To understand what we're seeing in the atmosphere, we need to understand what all of the inputs are into the atmosphere. Many of them are of human origin. And we're talking about, again, energy generation, which includes power plants, which includes traffic, vehicular traffic. It also includes industry and the manufacturing that goes on across the landscape. Alongside that, you have natural sources, and oftentimes vegetation releases a lot of hydrocarbons into the environment. And each of these sources can have molecules that are in common, but molecules that are very specific to that source. And we often need to measure many things in the atmosphere so that we can use those fingerprints of different sources to understand what their contributions are to the total mixture that we see. In trying to make that separation between the various sources, that's the information that we ultimately need in order to target places that we want to reduce emissions. And so understanding each contribution, as well as the reactivity of that contribution and its likelihood to result in harmful secondary pollution, play a role in how we will target policies and decisions on how to cut back.
Interestingly, the people in Korea thought that most of the air pollution was coming from China. Our study showed that majority of the pollution, at least during that time of the year, was made in Korea, and that they had the ability to do something about it.
Korean government is working for the 10 years air quality program right now. They started just years ago, and the outcomes from this KORUS-AQ program will be really beneficial for their plan and how to renew their plans to improve the air quality for the next 5 or 10 years.
Last year we delivered our rapid science synthesis, and in there we pointed out that diesel vehicles were a problem, that there was some industrial solvents that were unexpected and at high levels.
We didn't know what specific compound or what specific the issues will generate this, the PM problem and aerosol problem.
So one of the things we learned from KORUS is that they had the automobiles that were too clean in their model. It turns out there's a lot more diesels in Korea. 50% of their cars are diesel. And as we know now, that diesels are polluting more than we thought they were. And so one of the changes they've made since KORUS-AQ is they've increased the emissions coming from cars, and now they're getting a better air quality forecast. And they're also adding that toluene source, that solvent source, that they didn't realize how much there was and how good it is at making PM 2.5 and ozone.
And we found during this campaign, or we reassured that this toluene is a major player to reduce ozone and SOA, such as secondary organic aerosol.
And so those are two ways the air quality forecast has improved since KORUS-AQ.
Ultimately, what we're trying to do is try to understand what is the best balance of limiting emissions and improving air quality, but not degrading quality of life in terms of economic development.
At first, we didn't have the experience like this kind of huge program, big program before, so we didn't expect what will comes out of this program. But what we have done or what we have achieved during this program is really helpful for both of the scientific community in Korea and government side.
And so it's exciting to see the Korean government take rapid action on those activities. And so they're looking at reducing their electricity generated by coal, they're investigating those solvents, and we're talking with our Korean partners about a future air quality campaign there as well.
It's been very exciting to see over the course of a couple of years how a culturally diverse group that have a common understanding and appreciation for atmospheric science have come together synergistically to produce not only an amazing data set, but getting some really nice analyses out of it.
The Korean people understand this last KORUS-AQ campaign was very good.
It's very exciting to see how much we learned during the experiment.
The result of KORUS-AQ is unique in Korea. There is a lot of information about current air quality of Korea.
I think also we produce many scientific findings and some of the nice recommendations for the air quality control strategies. And these outcomes are really valuable.
So we are going to improve some policies based on this result of the KORUS-AQ campaign.
I didn't actually expect these outcomes. At first, we organized this program.
So this has been pretty exciting to actually be very connected to what's affecting the people in Seoul and around Korea.
The bottom line is it was really worth it to do this study. If we hadn't done all this detailed work, this detailed collaboration, then we wouldn't have the best information that we have now to give the advice.
We always want to improve understanding, but this time we got the extra benefit of having impact and having an audience in Korea that really wanted to understand what is causing the problem and what are the opportunities to do something about it. That's something that we don't always get on a campaign.